Good morning, students. Welcome back to Max Online class. In the previous class, you have learned real numbers. In the real numbers, I have explained 4 basic operations on zeros. Today also I am going to continue 4 basic operations on zeros. In the previous class, I have given 3 problems as homework. Exercise 2.6, second problem, first, second and third problem. Have you all completed? Okay, students, take your homework note and check your answers. Simplify the following using multiplication and division properties of surds. First one, root 3 into root 5 into root 2. Square root of 3 into 5 into square root of 3 into square root of 5 into square root of 2. Here everywhere order is same. So we can multiply. How we have to multiply? Root of 3 into 5 into 2 is equal to root 30. Next second one. Root 35 divided by root 7. It's equal to root 35 by root 7. It's equal to root a by root b is equal to nth root of a by nth root of b is equal to nth root of a by b. When we are using square root of 35 by 7, it's equal to 1 7 is 7, 5 7s are 35 is equal to root 5. Then the third problem, in the first two problem, it is the simplest form. So we have multiplied and here we have divided directly. Next here, cube root of 27 into cube root of 8 into cube root of 125. Can we write this in the simplest form? Yes, we can write it. Cube root of 27. 27 when we are factorizing. 3 table we can factorize. 9 3s are 27. Again 3 table 3 3s are 9. Again 3 table 1 3 is 3. So cube root of 27 we can write cube root of 3 cube. Next cube root of 8. Cube root of 8 we have when we are factorizing. 2 4 2s are 8. Again 2 2 2s are 4. Again 2 1 2 is 2. It's equal to 2 cube. Cube root of 2 cube is equal to 2. Next, again, cube root of 125. 25. When we are 125, when we are factories, 5 table. 2 times 10, 5 5s are 25. Again 5 table. 5 5s are 25. Again 5 table, 1 5 is 5. So we can write cube root of 5 cube. Here the order and power same. So we can cancel. Here also order and power same. Here also order and power same. So we are getting 3 into 5 into 2 into 5 is equal to 30. Now I am going to explain exercise 2.6 third problem. If root 2 is equal to 1.414, root 3 is equal to 1.732, root 5 is equal to 2.236, root 10 is equal to 3.162. Then find the values of the following correct to 3 places of decimals. Root 300 plus root 900 minus root 8. First can be write in the simplest form. Yes, we can write in the simplest form. Root 300 plus root 90 minus root 8. What's the simplest form of 300? 300 when we are factorizing, which table we can factorize? Yeah, 2 table. 1 2 is 2. 1 balance. 5 2s are 10. Next 0. Again we can factorize with 2 table. 7 2s are 14. 1 balance. 5 2s are 10. Again which table we can factorize? Yeah, 5 table we can factorize. When we are factorizing with 5 table, 1 5 is 5. Next 2 balance. 5 5s are 25. Again we can factorize with which table? Yeah, 5 table. 3 5s are 50. Next factorize with 3 table 1 3 is 3. So we can write root 300 is 2 square 5 square into 3. Here order is 2. So I am writing pair. So 2 square into 5 square into 3 plus next root 90. How can we do that? Root 90 also we can write in the simplest form. How can we write root 90 when we are factorizing? Which table we can factorize? Yeah, 2 table. 4 2s are 8, 1 balance. 5 2s are 10. Next, which table we can factorize? 5 table or 3 table. 5 table when we are factorizing. 9 5s are 45. Next, again we can factorize where? 3 table. 3 3s are 9. Again we can factorize the 3 table. 1 3 is 3. Here this 2 only having 3 into 3 we can write 3 square. This 2 not having the pair. So we have to multiply and write it. So how can we write? 3 square into 10. 3 square into 10. Next minus root 8. How can we factorize the 8? 2 table 4 2s are 8. Again 2 table 2 2s are 4. Again 2 table 1 2 is 2. How can we write it? 2 square into 2. Is it correct? 2 square into 2. So we can write it root 2 square into root 5 square into root 3 plus root 3 square into root 10. Next minus. How can we write this? Root 2 square into root 2. Okay. Which property we are using? Yeah, nth root of AB is equal to nth root of A into nth root of B. Here the order and power same. So square root of 2 square is equal to 2. Square root of 5 square is equal to 5. 2 into 5 root 3. Next square root of 3 square is equal to 3. 3 root 10. Next square root of 2 square is equal to 2. Minus 2 root 2. So 2 into 5 is equal to 10. 10 root 3. Next plus 3 root 10 minus 2 root 2. Can we add this? No, we cannot add. Why? Here root 3 order is same only, but the radicand is different. If we want to add, we have the radicand as well as order should be same. Here order is same but the radicand is different. So we cannot add. But here it is given. Root 2 value is given. Root 3 value given. Root 5 value given. Root 10 value given. Whatever we needed, we have to use that. It's equal to 10 into, what's the value of root 3? 10 into root 3 value? 1.732. Plus 3 into, next what's the value of root 10? 3.162. Next minus 2. What's the value of root 2? 1.414. Then we have to multiply. 10 into 1.732. Any number we have to multiply by 10 means the decimal point we have to move one digit after. So we can write 17.32. Is it correct? Yeah, 17.32 plus 3 into 3.162. 3162 into 3. When we are multiplying 3 2s are 6, 6 3s are 18. 1 balance, 1 3 is 3 plus 1, 4. 3 3s are 9. How many digits before want to put the decimal point? 3 digits. So we are getting 9.486. So we are getting 9.486 minus next 2 into 1.414. 2 into 1.414. So 1.414 without decimal point we have to multiply into 2. 4 2 is 8. 1 2 is 2. 4 2 is 8. 1 2 is 2. 3 digit before we have to put the decimal point. So we are getting 2.828. Then when we have to add 17.32 plus 9.486. 17.32 plus 9. Listen carefully how we have to add. 9 point. We have to write down of that. Here also point. 9.486. When we are adding here 0. 0 plus 6. 6. 8, 2 plus 8, 10, 1 balance. Next, here 1 plus 3, 4, 4 plus 4, 8. Next, 7 plus 9, 16, 1 balance. 1 plus 1, 2. So, 26.806. Minus 2.828. How we have to subtract? 26.806 minus 2.828. Here we cannot subtract. We have to borrow it. Here 7 will be get. Here what will be get? 9. Here 16 will be get. 16 minus 8. 8. Next 9 minus 2. 9 minus 2 is 7. Here also 7 minus 8. We cannot subtract, so we got to borrow it. Here 5. Here 17. 17 minus 8. 17 minus 8 is 9. Next 5 minus 2. 3. Next 2. 23.978. What is the answer? 23.978. So the answer is 23.978. Very easy problem. First, root 300. What's the simplest form of root 300? 10 root 3. What's the simplest form of root 90? 3 root 10. What's the simplest form of root 8? 2 root 2. Here, the radicand is not equal. Order is equal. Radicand is not equal. So, we cannot simplify. So, but root 2 value, root 3 value, root 5, root 10 is given. We have to use here root 3 we have to use. So, 10 into root 3 value 1.732. 3 into root 10 value 3.162. Minus 2 into root 2 value 1.414. We have to multiply 10 into 1.732 means 1 digit. We have to move the decimal point 1 digit right. So 17.32. Here when we are multiplying 9.486. Here 2 into 1.414 2.828. This 2 we have to add. So 26.806 minus when we have to subtract 2.828. When we are subtracting, we are getting 23.978. Next, exercise 2.6, fifth problem. Can you get a pure Z when you find the sum of two Z's? Can you get a pure Z when you find the sum of two Z's, the difference of two Z's, the product of two Z's, the quotient of two Z's? Justify each answer with an example. The question is, can you get a pure Z? Can you get a pure Z when you find the sum of two Z's? When we are adding two Z's, whether we can get a pure Z? With an example, we have to explain this. We have to find the answer. First one. Yes, we can get a pure Z when we are adding two Z. The sum of two Z, we can get a pure Z. So the answer is yes. Example, I am giving one example. You can use another example also. Okay. Consider 2 root 3 comma minus root 3. To third, I am selecting 2 root 3 minus root 3. We have to find out the sum. So, 2 root 3 plus minus root 3 is equal to 2 root 3 plus minus root 3 is equal to 2 root 3 minus plus into minus root 3. Okay, you can give another example also, but when we are adding the two thirds, we have to get a pure third. Like that, we have to select another example also. Here, what is the coefficient of here? What is the coefficient? 2. What is the coefficient here? 1. 2 minus 1 into root 3. 2 minus 1 is equal to 1. 1 root 3 is equal to root 3. Is it a pure third? Is it a pure third? Yes, it is a pure third. Why? The coefficient is 1. When we are getting the coefficient, if the coefficient is 1 means that is a pure third. Next, the difference of two thirds. We have to find out the difference of two thirds. Whether we can get? Yes, the answer is yes. Example, one example I am giving 5 into cube root of 2 minus, next consider 5 into cube root of 2 comma 4 into cube root of 2. 5 into cube root of 2 comma 4 into cube root of 2. Here the coefficient is, here what is the coefficient? 2, here 1. The positive, here negative, like that I have selected. Here what I have selected? 5, 4. Coefficient is 5, 4. Here also you can select 5, here 4. But the symbol should be plus and minus. Then only we can get the answer here. Here both also same symbol. Plus plus. 5 cube root of 2 comma 4 cube root of 2. We have to find out the difference. Difference is equal to 5 cube root of 2 minus 4 cube root of 2 is equal to, here what's the coefficient? 5. Here what's the coefficient? 4. 5 minus 4 into cube root of 2. 5 minus 4. 1 cube root of 2. It's equal to cube root of 2. Here it is a pure short. It is a pure short. Next, third question. Product. We have to find out the product. The product should be a which number? Pure short. Can we get? Yes, we can get product of two short be a which one? Pure short. We have to give one example. Example. Consider. You can give another example also. Cube root of 2 comma cube root of 3. Cube root of 2 comma cube root of 3. Product. We are finding the product. What's the product here? Say product is equal to cube root of 2 into cube root of 3. It's equal to cube root of 2 into 3. It's equal to cube root of 2 3s are 6. Is it a pure short? Yes, it is a pure short. It is a pure short. So, we can get the product of two short be a which one? Pure short. Every shirts when we are multiplying we cannot get a pure shirt, but we can give the example 2 shirt. When we are multiplying 2 shirt, we can get a pure shirt. Fourth one, quotient. The quotient of 2 shirt be which one? Pure shirt. Can we give example? Yes, the quotient of 2 shirt be a pure shirt. We can give example as consider cube root of 15 and cube root of 5. 2 numbers. So I am selecting cube root of 15 and cube root of 5. We have to find out the which one? Quotient. Quotient is equal to cube root of 15 divided by cube root of 5 is equal to cube root of 15 by 5. 3 is equal to cube root of 3. Is it a pure shirt? Yes, it is a pure shirt. So, with a quotient be a, here the quotient be a which one? Pure shirt. We can give example for the quotient be a pure shirt. Once again I am explaining this. Can you get a pure shirt? When you find the sum of two sets, the difference of two sets, the product of two sets, the quotient of two sets. Justify each answer with an example. First, we have to find out the sum of two sets, whether it is a pure set. The question. First, yes, we can find out. We can give example for sum of two sets be a pure set. I am giving one example. Consider 2 root 3 minus root 3. You can give another example also. Can you say one more example? Yeah. 5 into cube root of 2, comma, minus 4 into cube root of 2. When we are finding the sum, this be a pure set. Can you give another example? Yes, we can give another example also. 3 fifth root of 5, comma, minus 2 fifth root of 5. When we are adding this, what we are getting? Yeah, 1 fifth root of 5. That is a which one? Pure set. Okay. Next, second question. Difference of two sets. Difference of two sets. Can we give example for difference of two sets be a which one? Pure set? Yes, we can give example. Yes. Example, consider 5 into cube root of 2, 4 cube root of 2. When we are finding difference, what we are getting? Difference is equal to 5 into cube root of 2 minus 4 into cube root of 2. Then that is equal to 5 minus 4 into cube root of 2 is equal to 1 into cube root of 2. It is a pure set. It is a pure set. We can give another example also. Then the third question, product of two sets. Whether the product of two sets be a pure set. Can you give example? Yes, we can give example. Yes, consider cube root of 2, cube root of 3. Product when we are finding cube root of 2 into cube root of 3 is equal to cube root of 2 into 3 is equal to cube root of 6. Can you give another example? Yes, we can give another example also. Cube root of, otherwise fifth root of 6 into fifth root of 2. When we are multiplying, what we are getting? Fifth root of 2 into 6 into 2 is equal to fifth root of 12. It is a pure set. So we can give another example also. Next. Can you get a pure set when we have the quotient of two sets? Okay, can you get a pure set? The quotient of two sets. Yes, I am giving one example. Consider cube root of 15 and cube root of 5. When we are finding the quotient, cube root of 15 by cube root of 5 is equal to cube root of 15 by 5 is equal to cube root of 3. It is a pure set. Next, sixth question. Can you get a rational number when you compute the sum of two sets? Can you get a rational number before problem? Can you get a pure set when you compute sum of two sets? Here, can you get a rational number when you compute the sum of two sets, the difference of two sets, the product of two sets, the quotient of two sets? Justify each answer with an example. First one, can you get a rational number when the sum of two sets? Yes. We can get a rational number, the sum of two sets. For example, consider 5 plus root 3 comma 5 minus root 3. 5 plus root 3 comma 5 minus root 3. When we are finding this sum, what we are getting? You can give another example also. Okay. When we are adding, what we are getting? 5 plus root 3 plus 5 minus root 3. Root 3 cancel. 5 plus 5 is equal to 10. It is a rational number. It is a rational number. Second one, can you get a rational number when you compute the difference of two sets? Can you get a rational number when you compute the difference of two sets? Yes, we can get a rational number when we compute difference of two sets. Example, can you give example? Yes, we can give example. I am giving one example. 3 plus cube root of 2. 3 plus cube root of 2 comma minus 3 plus minus 2 plus cube root of 2. Okay. 3 plus cube root of 2. Next, minus 2 plus cube root of 2. When we are finding the difference, we have to find out the difference. When we are finding the difference, what we are getting? 3 plus cube root of 2 minus 2 plus cube root of 2. Okay, you can give another example also. So 3 plus cube root of 2 minus into minus plus minus into minus plus 2. Next, minus into plus minus cube root of 2. Okay, difference when we are selecting, here also plus cube root of 2 plus cube root of 2. Like that we have to select plus cube root of 2 plus cube root of 2. Here when we are selecting plus root 3 minus plus minus. Okay, like that you have to select it. Here it will be cancel. 3 plus 2 is equal to 5. 5 is a rational number. 5 rational number. Next, what's the third question? Third question. The product of two sets. The product of two sets. Third one. Can you get a rational number? The product of two sets. Yes, the answer is yes. Example, I am giving one example. Consider cube root of cube root of 81 and cube root of 3. Cube root of 81 and cube root of 3. Product is equal to cube root of, I am selecting another number, cube root of 9 and cube root of 3. Cube root of 9 and cube root of 3. Product, when we are selecting, what we are getting? Cube root of 9 into cube root of 3 is equal to cube root of 9 into 3 is equal to cube root of 27. 27 means cube root of 3 cube is equal to 3. It is a rational number. You can give another example also. Another one example I am giving. 5 plus root 3, 5 minus root 3. Another one example. When we are finding product, what we are getting? 5 plus root 3 into 5 minus root 3 is equal to a plus b into a minus b means a square minus b square. So 5 square minus root 3 the whole square, it's equal to 25 minus 3 is equal to 22. It is a rational number. Then the fourth one. Quotient be a rational number. Can you give example? Yes. Can you get a rational number? The quotient be a which one? Rational number. Example. Cube root of 16 and cube root of 2. When we are finding quotient, we are getting what? What we are getting? Quotient is equal to cube root of 16 by cube root of 2. It's equal to cube root of 16 by 2. It's equal to cube root of 8 is equal to cube root of 2 cube is equal to 2. It is a rational number. Exercise 2.6, third one, first problem homework. Please complete the